Today we will continue Chapter 8 and discussing area and all our area formulas. Today we will look at Lesson 8.5, which talks about areas of parallelograms and rhombuses, or rhombi, if you'd like to talk about pronounce it like that. The area formula for a parallelogram is simply base times height. Now, very similar to a rectangle, because if you look at a parallelogram, if I were to take this distance from this vertex straight down perpendicularly, and we can call that the height, that's the height of that parallelogram. But if I were to take this little triangle, cut it out, it would actually slide right in here. Well, then the base would be the actual base length, which would be up here or down here, this whole length, times that height. So that's why the area formula for a parallelogram works, because it is a rectangle. If we just cut this little triangle off and slide it over here, it would fit perfectly right here. So we actually have the same formula for a rectangle as we do a parallelogram. All right. So there's your formula. It's area is base times height. Now what we need to look at is, again, what is the height? We have to remember that the height is the perpendicular distance between the bases. Now we can measure the height anywhere along here that we want it, as long as we measure perpendicularly. Remember, we measure at a right angle because that's the shortest distance. If we measure at a slant, well, that's actually longer than it is as it is if we measured perpendicularly. Alright, so if we look at this guy, we can actually measure the height of a parallelogram outside of the parallelogram as well. You just have to remember that if we took this side and we extended this side all the way out, well, we could measure down to that. And you imagine this parallelogram was sitting on a little table here, well, that would be the table base. The height of that parallelogram would be the distance from the table to that other base, no matter where you measure, as long as you measure at a right angle. Right? So that is the formula for the area of a parallelogram. Now the formula for the area of a rhombus, a little bit more difficult, is 1/2 times d1, that's diagonal 1, times diagonal 2. So what we need to remember is the diagonals of a rhombus, the distance from a vertex to another non-consecutive vertex, vertex to vertex, that's one diagonal, that's another diagonal. Now it does not matter which one you use. That would be the commutative property multiplication. We could flip-flop either of those diagonals. Doesn't matter. Now, this formula actually stems from a rectangle as well, that if we were to draw a little rectangle all the way around here, well, the area of that rectangle is base times height, but if you look at the base, that base is actually that diagonal length right there, and this height here is actually that diagonal length right there. So we have diagonal 1 times diagonal 2, but then if you look at that, that rhombus is actually half of that. If I were to cut these little triangles out right here that I'm coloring in, it would fit perfectly right to that guy. This little triangle would fit right to that guy, and that guy. So this is actually a half of a rectangle. So that's where that half comes from, and then the diagonal 1, diagonal 2 is the rectangle that contains that rhombus. Now, do you need to remember that? No, just remember the formula, and you will be quizzed over these formulas. So here we go. Let's do some area calculations. So first off, we have to recognize what shape is this. This is a parallelogram, so our formula is simply base times height, which would be the base of that is 12 times the height, which is 6. 12 times 6 is 72. So we have to remember that when we calculate area, it's units squared, so it would be 72 inches squared. Done. Very simple, just like a rectangle. So base times height, the base of this guy, now what we have to be heads up on is the base. I turn this guy, the base is 20. The height is still 12. 20 times 12 is 240, so we'd have 240 square feet. All right. Same thing over here for number 3. Now we got to be heads up on this guy. We have to look at what is the base and what's the height. This is part of the parallelogram. That's the base. So when we write our formula down, we know that the base is 4. Now the height, is this perpendicular to that base? That 9 is not perpendicular to that base. That's an acute angle, not right angle. So what we have to do is go look out here. Is this perpendicular to my base extended? Yes, it is. So that's my height. So the area of this guy is simply 4 times 8, which is 32 inches squared. And I'm going to continue to harp on you. Label. Right. So now when we go to this guy, we want the area formula is base times height. So if we look at the base of this, we have 4. Not the 9, not the whole thing. It's just that part of the shape, that part of the parallelogram. That's the base 4. That base up here is 4 as well. Times the height. Now the height would be the perpendicular distance. This is not perpendicular. That's an obtuse angle. The height is all the way out here, just like it was over here. But we don't know the height. But if you look at the little right triangle we created here, we could calculate that very easy. Here we go again. Pythagorean theorem. 8 squared plus 5 squared equals 13 squared. We know that 13 is the hypotenuse because it's opposite of that right angle. So we would go ahead and subtract that 25 over. We would get 144, and we would square root it, square root it. The height then is 12. Right? So our height over here, we calculated this with a little bit of Pythagorean theorem. That's 12 is 12. So we take 4 times 12. That would be 48 meters squared. So again, I'm starting you trying to get you to figure out, what do we have to use, or what is the height? What is the height? How do we find it if we don't have it? And most of the time, we're going to find it by simply doing the Pythagorean theorem. All right. Let's go to these rhombi. Again, you can pronounce it rhombi or rhombuses. I prefer rhombi. Alright, so when we go to calculate the area of this rhombus, we know that the formula is 1/2 d1 times d2. And remember, those are the diagonals. And you also have to remember that it's irrelevant which one you use first. Okay. So what we need to look at is, what is diagonal 1? I'm going to call this diagonal 1. 4 and 4, so that whole diagonal is 8. This diagonal, diagonal 2, is 2 and 2, which is 4. Now I'm going to do this like I worked a triangle. I like to just take half of 8 is 4. 4 times 4 is 16. So that is 16, label meters squared. Alright. Alright, so let's go to number 6. Now again, I'm showing you 3 different ways that I can do this. What we have to remember is the distance from here to here is 10. This guy over here is also 10. Now I had it marked over here, but I don't here. So we kind of have to remember that. This distance is 7, so this guy is 7 as well. That goes back to the properties of a parallelogram. And number 5 was that the diagonals bisect each other. Well, that's the same thing. They're cut into 2 equal halves. So we go A equals 1/2 d1 times d2. To me, I would write down the formula every single time. That way you memorize these, because you will have to for the test. Diagonal 1 would be 10 and 10, which is 20. Diagonal 2 is 7 and 7, which is 14. So now we do that calculation. Again, you can throw this in your calculator, but to me that's head work. Because if you take half of 20, that's 10. 10 times 14 is 140. So our label is 140 meters squared. All right. So let's go to number 6. Number 6, we would have the area formula. 1/2, that is a rhombus. 1/2 d1 times d2. And I specify on the test as well as which shape you have. Now look how I labeled these. I labeled that the distance from here to here is 10. And then I also labeled that the distance from here to here is 6. So we have the whole diagonal length here, so all we have to do is substitute it in. Now I'm going to flip-flop this one. I'm going to go 1/2 of 6 times 10. Now the reason I did that is I love multiplying by 10. So I wanted to keep the 10 whole here. So what we could do is half of 6 is 3. 3 times 10 is 30. So we have a 30 meters squared as our area. Same process on number 8. You'd have 1/2 times diagonal 1, which I'm going to go 18, times diagonal 2, which is 30. Now I did it this way again because I like half of 18 is 9. 9 times 30, remember 9 times 3 is 227, so that's 270 square feet. So that's our area for that. All right. So again, now we can do some work backwards problems like we have been doing. And again, I want that 4-step process here as we go. So we would have find the missing side length to show your work. Step 1. A parallelogram has an area of 56 inches squared. So the first thing we should do is get our formula down. Area equals base times height for a parallelogram. Step 2. We said we're just going to go ahead and substitute everything in that we know. The area is 56, so the A is 56. The base is 8 inches, so we know the base is 8 inches. Now we're trying to find the height. We don't know the height, so we're going to leave that variable there. All right. Step 3 is simplify anything we can and solve. Well, we can't simplify anything here, but we sure as heck can solve it. So we're going to divide by 8. Divide by 8. 56 divided by 8 is 7. And step 4 is come back and label your answer. So when we come back and label our answer, it will be 7 inches because we found the height. Now we could come back and do this in a complete sentence like ideal, but I'm not going to make you do that. You could say, well, the height of the parallelogram is 7 inches. But we don't have to do that. Just make sure you label it 7 inches. All right, number 10. A parallelogram has an area of 120 square feet. So again, step 1, get the formula down. This is going to be so, I know this is very basic, a nice easy solve, but once we get more difficult formulas in the end of this chapter and into chapter 9, you're going to want to do these steps. The area is 120. Now notice here, we know the height is 10 feet, but we don't know the base, so we're going to leave the base here, and we know the height is 10. So again, we have b times 10. Step 3 says simplify anything we can. We can't simplify anything, but we can solve it, so we divide by 10. I love dividing by 10 because that means I just cancel my 0 out there. And we get a height of 12. So we come back in part 4 as we go ahead and label answer as 12 what? 12 feet. Okay, so there's your answer there. There's your answer again. Again, we're going to get more difficult ones like this, so you do a good job at showing your work now, getting organized in your work, following these steps, and it's going to make the rest of this chapter and next chapter a lot easier. Now, a rhombus has an area of 100 meters. So again, step 1, let's go ahead and jot down the formula. For a rhombus is 1/2, that's the goofy one, d1 times d2. Let's substitute in, we know a rhombus has an area of 100, so we can throw the 100 right there. We got the 1/2. I know one diagonal is 10. I'm just going to throw that in the first one. In the other diagonal, we don't know. Now, it's irrelevant where we put that 10 here. It could go either way, just like the last one, it didn't matter. But now, step 3, that was 1, that was 2. Step 3, I always said simplify. Well, the last couple, we didn't have anything to simplify. Here we do. So what I'm going to do first is I'm going to take half of 10. Half of 10 is 5 times d. Once I multiply these two together, I get 5. That half is gone. Alright, so we're still simplify solve. We're still step 3. We can divide by 5. Divide by 5. 100 divided by 5 is we find our other diagonal to be 20. That's what 100 divided by 5 is, 20 nickels in a dollar. So now step 4, we need to come back and label our answer. The other diagonal would be 20 meters, just meters. This is not an area calculation. We started with that. Alright, next one, rhombus has an area of 56 meters squared. So again, the first thing we need to do is let's jot down our formula. I know this is going to get redundant, monotonous, writing this formula down every time, but I promise you it will be beneficial to you. So you memorize these formulas. So area is 56 equals 1/2 times one of the diagonals is 16 meters. Now remember, it doesn't matter which one we plug it in for. I'm going to go ahead and do the first one times the other diagonal. So step 3 said simplify and solve. Well, we can simplify before we solve here. We know that half of 16 is 8, so we have 8 times d. And again, these two guys combine to get that. Now it's a simple solve. Now we just divide by 8. Divide by 8. That's Gandhi. So d is 7. Label it. 7 what? We're talking about a length, so it's 7 meters. Remember, labels are important because that tells me what did you find. Did you find length? Did you find area? Did you find volume? Alright, so let's go into these guys. I'm just going to do one of these with you. And then we'll look at these guys here in a little bit. We want to find the area of the following polygons. Now these are compound polygons, and so what we're going to have to do is find the area of each, and then we're going to go ahead and add them together. So again, I'm going to organize my work. We have two shapes, a rectangle and a parallelogram, so I'm going to go area of the rectangle, base times height, area of the parallelogram, same formula, base times height. Hey, that works out nice. Okay. So when we go to the area of the rectangle, the base is 14, the height is 6. So that's 14 times 6, 16, 24, 84 meters squared. We don't even have to label it yet if you don't want to. Now the parallelogram, let's look at the parallelogram. What's this base? Well, again, if we don't know it, we're going to have to look across. So that base is 14. The height of that, remember the height is perpendicular to the base, is 5. So we take 14 by 5, that's 50 and 20, which is 70 meters squared. So then find the total area, we just add those two together. So you take 84 plus 70, and we get a total area. I like to label it as total, because that's my total area. 84 plus 70, which is 154. 154. Now we have to make sure we label meters squared. All right. So again, this is kind of warming you up for chapter 9 when we do surface area. All right. I'm going to backtrack. I'll come back to 14 here in a little bit. Again, let's go here. Now what we have is we have a rhombus and a triangle. So again, the way I'm going to set it up is I'm going to get myself organized. The area of the triangle is 1/2 base times height. The area of my rhombus is 1/2 d1 times d2. Okay. So when we go to find the triangle, we need the base, we need the height. Oh man, we don't have the height of that triangle, right? But we can find this. If you remember, a rhombus is divided up into 4 little right triangles. This is 8, 15. So what we have is we have this little triangle inside there. We actually have 4 of them that are 8, 15. Well, how do we find that third side? There it is again. Good old Pythagoras. So we're going to go 8 squared plus 15 squared equals c squared. You end up finding that that's 289. 64 and 225, that's 289 equals c squared. Square root it. You find that c is 17. That means that each side of this rhombus is actually 17. 17. We could actually go into some perimeter calculations here as well if we wanted to, but we're not going to. So the base of that triangle is 10. The height is 17. So we have 1/2 times 10 times 17. Now here's our calculation. Half of 10 is 5. 5 times 17 is 50 and 35. 50 and 35 is 85. Again, we don't have to label it here, but I'm going to go ahead and do that. So that's the area of the triangle, is 85 units squared, 85 centimeters squared. Now the rhombus, we actually have everything for the rhombus. Remember, we're looking for diagonals here, so what we have to think a little bit here. Let's go diagonal 1. Now this is 8. This is 8, so the whole diagonal is 16 times the other diagonal, which would be 15 and 15, which is 30. Now this works out good this way because half of 16 is 8. 8 times 30, 8 times 30, 8 times 30, 8 times 3 is 24, so that's 240 centimeters squared. So then to find the area, the total area, and we're going to have problems just like this where we have to set up here, and all through this chapter and next chapter. So the total area is we just add these two together. So you take 85 plus 240 and you get 325 centimeters squared. So there's our total area right there. All right? Good. Alright, so now what we're going to do is we're going to use the following. We're going to do some conversion rates here, and I really like these. We're going to do these this chapter, next chapter, the following chapter, when we convert things. Okay, very simple to do, a nice simple cross multiplication, and I'll show you how to do these. Use the following conversion rates to convert the given measurement into the new unit. So what we want to do is we're going to want to convert 7 feet to inches. So we're trying to figure out 7 feet is how many inches. Okay, so what we need to do is we need to look for the conversion rate. We're looking for feet and inches all the way across. Well, we actually hit it on the first one, is that 1 foot is to 12 inches. Now the nice thing about these is you can crisscross and mix these up a little bit, and you can do these several different ways with the same cross multiplication and still get them right. What I did is I said 7 feet over inches. I said feet over inches. So when we go to our conversion rate, we make sure that we have feet over inches. Again, we could have done inches on top and got the same answer. Now how do we do this? Simply cross multiply. I always like to start with my x. X times 1 is x. 7 times 12 is your answer. 7 times 12 is 84. Now what's your label? Inches. So 7 feet actually equates out to 84 inches. Now most of you, I'm guessing, knew that, hey, there's 12 inches in a foot. So if you have 7 feet, 7 times 12 is 84. Good. I just showed you another way. The reason I like to do it this way is because it's not always a multiplication. So if we look at this, number 17, we take 8 meters to feet. Now a conversion rate from meters to feet we'll look at here in a second. We want to convert 8 meters and try to figure out how many feet that is. Okay. Again, we could have done x feet over 8 meters here, flip-flop that. That's fine. It would have been worked out the same as long as we would have done this side the same. So when we go to do our conversion rate, we need to look at it as meters over feet. So we match up meters up top, feet down low. Let's go find our conversion rate that deals with meters and feet. Nope. Yards and inches? Nope. Meters and feet. Boom, there it is. This says that there are 3.28 feet in 1 meter. That's over a yard. So when we set this up, it would be 1 meter, 3.28 feet. Now what we can do is simply cross multiply. Start with your x. X times 1 is x. We take 8 times 3.28. 8 times 3.28 is 26.24. Now when we look at our label, feet. Alright? I'm going to jump down here, convert miles to kilometers. I'm going to do 2 more of these, and then you can be on your own. So we're going to go 8 miles to X kilometers. So we have miles over kilometers. And what we look, we have 8 miles over X kilometers. Let's go find a conversion rate that deals with miles and kilometers. No, no, no. Miles and kilometers. So 1 mile is 1.6 kilometers. With miles on top, kilometers on bottom, we are set. So we go x times 1 is x. We would also go 1.6 times 8, so we take 8 times 1.6, and your answer is 12.8. Now look at your label, 12.8 what? What did we find? Kilometers. So 8 miles is actually 12.8 kilometers. All right, let's go to the next one, 15 feet to meters. We want to convert 15 feet to meters, so we're going to go 15 feet, convert that to x meters. All right, so we come over here, we should have feet up top. We should have meters down low. So let's go look at our conversion rate, feet to meters, no, feet to inches, yards to inches, meters to feet, that's okay. So we look at feet, we have 3.28 feet, and then we have 1 meter. Now this one works differently because when we go to cross multiply here, you can see what happens. We have x times 3.28. Well, that is 3.28 times x equals 15 times 1, which is 15. So all we have to do here is we got one more step. We have to divide by 3.28 and divide by 3.28. So that's gone. So we have 15 divided by 3.28. Your answer is 4.57. I'm going to go ahead and round that to 4.57. So approximately 4.57. What's our label? Meters. So that's our answer. Now, I'd round that to the nearest hundredth. You could do 10th there and do 4.6 meters, approximately. Right. So that's how we convert. Now what I'm going to do is I'm going to go number 22, and we're going to go ahead and find the area in square feet. Now notice the difference here. I have square feet as my label here is what I want it calculated as, but look at what I have on my label, 7 meters and 10 meters. So what I'm going to do first off is I'm looking for meters to feet. So we're going to go back here and look at our conversion from meters to feet. And there it is. 1 meter is 3.28 feet. So I'm going to write that down here. 1 meter equals 3.28 feet. So what we're going to do is we're going to convert both of these to feet right off the bat. So we're going to say, all right, 10 meters is how many feet? If we know our conversion rate is that 1 meter is 3.28 feet. Now notice what I have, meters up top, feet below. Now we can simply cross multiply. X times 1 is x. 10 times 3.28 is 32.8. So 10 meters is 30.28 feet. So instead of having 10 meters here, we can have 32.8 feet. Okay, let's do the same thing here with this. So to calculate this, we would take, all right, 7 meters is how many feet? We do our conversion rate the same thing. 1 meter is 3.28 feet. We simply cross multiply again. X times 1 is x. So we take 7 times 3.28, and we get 22.96. 22.96, we could go ahead and round that to 23 feet. So instead of having 7 meters here, we could have 23, approximately 23 feet. Now notice what we're doing. We're approximating here, so when we approximate, our answer is going to be kind of approximated as well. So when we go to calculate our area then, no problem. The formula for the area of a parallelogram is base times height. Let's look at what we have. Now the base we had at 10 meters is 32.8 feet times the height, which we said was 23 feet. So we take 32.8 times 23, and we get 754. Okay, I'm going to put approximately 754.4 label square feet. So that is our area in terms of square footage. Now, real easy in terms of meters, in terms of square meters, it would simply be 10 times 7, which is 70 meters squared. But we wanted it in square feet. All right? So your job here is to finish your homework, lesson 8.5. If you do have any questions, make sure you come see me, please. Good luck, and again, if you have questions, come see me in seminar before or after school.